Welcome back. Our next presenter is Filipi Pires, and Filipi's presentation is titled Dissecting and Comparing Different Binaries to Malware Analysis. Thank you so much, Filipi, for supporting Great Hat and the Red Team Village continuously, throughout the years. And I'm looking forward to your presentation, and take it away.
Hello guys, I'm so glad to be here. And today we're gonna talk about dissecting and comparing binaries to analysis when we talking about the malware analysis, right? My name is Filipi Pires, and this is my contact in the Twitter, GitHub, and Medium. I use a lot the LinkedIn profile, not profile actually, in social medias. If you have any doubts or any questions, please, this is my contact, and I am available to talk to you, right? So, some information about me. I have been working in a hacker security as a global research manager, right? This is the Brazilian company. I am a founder. This course is about malware analysis fundamentals. And now, not now, I started to work in this company, Zoop Innovation. I am responsible to Zoop Security Labs. I am a research and security manager as well. I'm responsible to provide many research in antivirals and many different sensors of security products, right? And this is a Brazilian company as well. And this is like a software house responsible to create software apps and applications. And as you can imagine, the kind of softwares and apps, right? So here's some papers, or not papers, in this case it's article that I was wrote. Yeah, I published it in a Pentesting magazine, a Forensic magazine, and the Cybersecurity Hub as well. This is not my idea here is not to hack the NSA or FBI or Microsoft. My idea when I published this kind of articles is to provide some basis, So my idea is to talk about the basis, what the fundamentals is important when you talk about the security products or malware analysis, or maybe threat hunting, or maybe pen testing. So we need to know about the basis. During our conversation now, I will explain more about this, right? So here are not another papers that I was wrote, right? And you can read in my social medias or this magazine as well, right? So the first step that we need to do when you talk about the malware analysis is to identify, right? This step is called identification, right? Because we have the artifact. We don't know if the artifact is malicious or not. We need to understand if this malicious or this artifact actually is malware, software malicious, or maldoc, document malicious, right? This is the first and very important part, right? After that, you can choose what the kind of analysis you will choose, if you use static analysis or dynamic analysis, right? After that, after you realize or you executed it, you can prepare a report, right? Actually, this kind of step, it's very important because you need to present it to your manager, your tech lead, your coordinator, maybe, and you can prepare many of these informations that you analyzed before, right? After that, you can improve your security defenses mechanism, right? This is the main point here, because, for example, if you try to explore any antivirus in your environment, right? Maybe you can try explore many DLL injections. You can try using another different malware, or maybe using some exploits to try explore your antivirus solutions. This is a very interesting point. You can present this to your manager or your tech lead, and when you find any for example, vulnerability, maybe bugs, maybe I don't know, failures in your softwares, in your security software, for example, you can improve, you can adjust many settings inside your platform, right? And after that, you can prepare the beautiful word has no like a cyber threat intelligence or CTI, right? You can build it. You can build this kind of intelligence in your company. I know maybe you don't have a big company, you have a small company, but you can work with, for example, IOCs, indicator of compromise, or maybe you can work with maybe EOA or EOA. It's like an indicator of attack, and you can build it, right? This is the mainly point when we talk about the malware analysis, because when you mention malware analysis, maybe the people that was watching me now maybe are thinking, for example, okay, if I have this kind of knowledge, maybe I can work in a SOC or maybe in a support, but you can receive this kind of knowledge and you can improve it. You can work, for example, a threat hunting or threat hunter, a person that realize or execute this kind of work, right? Or you can maybe do this research as me, for example, because I am creating this in my company now in HackerSec and Zoop Innovation as well. And my idea is to put this kind of professional guy, this is the malware hunter, in a top of the tower, right? The idea is to put in the research guy in the top of the tower. This is my idea, because when you talk, for example, with many companies in the world, for example, this kind of person or this is a skill it's not clear if this guy is working with a SOC, with a SASAR, for example, in a CSIRT, or maybe in a support team, or maybe in a red team or blue team. It's maybe a confusion in many companies. So this is my idea to put in the top of tower, because this guy have a defensive, essence, but the mind, it's totally offensive. That's my idea, right? And after that, you can create the strengthening, your cyber resilience, because the threats are changing all the time, right? This is maybe not a life cycle of the malware analysis, but it's one suggestion, right? It's one idea, that's my suggestion for you, right? So the first step is static analysis. It's very simple. Usually this is the first step used by malware analysts, because this is usually it's described of the process of the some programs, maybe the structure, or maybe what the function is called by any DLL, or maybe called by any a library. For example, if you are analyzing, for example, a Unix platform, right? And usually this program itself, it doesn't run at this time, right? Because of course it's depending of the program that you can, for example, use in your analysis, but usually it's more safe, right? Because it's not 100% safe, but usually it's more safe because you not put in real time, right? The analysis, it's not in real time. That's a simple point here when you talk about the statistic analysis, right? The second step is dynamic analysis, just to explain for everyone that was watching now, right? The dynamic analysis is based as just in behavior, right? Basically, it's the interactions that the malware has with the files inside the system's operation, or maybe what the document, maybe this file can call it. But usually you put in this sample inside of the virtual machine, one environment controlled, right? You run the sample inside this environment and you can analyze this behavior, right? So usually you can automatize many this kind of analysis, right? Because today you have many websites with antivirus engines to try execute your suspicious files, right? And you can use as well another concept called sandbox. This is basically it's a controlled environment that you can put your sample inside this product. For example, you can run and you can look in all DLLs, and many informations are called. But the big point, the very important thing here is, okay, I put my sample inside this sandbox, but what the response, what the answer are receiving in report, I can understand what the DLL are called, because I understand very well in low level, in the kernel level or the user level. I can understand this because, I have the automatization tool, but I need to interpreter. I need to not translate, but you need to understand what this report is talking, That's very important thing. Because of this, that's my mission now here, to try explain some basis for you, right? So, okay. So here I have a demo I will show in my machine, by the way. Okay. So I will try put here, I will pray to the, the lords of demo to try. Let me check here. I have here some samples, right? I have, by the way, here file Linux 32. Yes, this is a simple executable file, right? So if I check here another in a wheel machine, let me check here what I have here. A simple file. Okay, let me check here. If I use file command, I can find here in this case, it's a portable executable from Windows, from Microsoft, right? So you have different files here to understand if it's malicious or not. Let me check here. I have another different here. Let me check here. I have a bill. Let me check here. Bill file. Bill. This is a PDF file, right? It's a PDF file. Okay. So, but here I would like to try explain about the basis, right? Because we're gonna talk about file command, right? I don't know if you read something about this, but what means file in this case? File determining file type. I know, Filipi, but how this kind of tools, or this tool in this case works? That's a simple and very important point, right? Because when you put this command inside your machine, this file or this tool actually will run or run in your environment, and you show some answer, right, in the screen. But how this tools works, that's important, because if you read here, you can read here. The magic tests are used to check for files each data in particular fixed format. Maybe you are thinking now, and maybe I know Filipi show me about the man of files, but here you can understand something, because here you can understand those format is defined in elf.h. So maybe here we have interesting information. If you for example, if you check here, for example, if I put here, for example, no, let me. Oh yes, I will open. Okay, so here you can, if you see here this information, right, that I was received here in the month from file, you can read here. This file defines the standard ELF types, structure, and macros, right? And here below you can read another information about the structure, because here in the beginning you can read here the ELF files header. This appears at the start of every ELF file, right? You have here 16 bytes, the first array of the name identity, and you have the magic number and others information. So we have here, for example, the magic number. So what means this in this case, magic number? Here you have the key, right? So these files have a magic number stored in particular place near the beginning of the file that tells the Unix operation systems, right? So what this means in this case, it's very simple. The file command has a database responsible to provide all this information, to find all those magic number in the beginning of the file, right? So here, I will show you now here, for example, I have here the, I downloaded this file code to look inside this to show you this information, right? So here you can read many informations here of this kind of database. For example, if you, read the information of JavaScript, in this case here, okay? So JavaScript, let me show you for you here. JavaScript, we have here many informations in the beginning of the file. In this case, is the magic number of the file. You have many rules here that you could use. That basically this file command used to identify the file in this case, if it's executable or not, right? So let me show you some example now here. I will create this file, the name malware.txt, right? Is it malicious? Is it malicious? Let me write here. Okay, this is a simple question. I will read this information. In this case, perfect. Let me use file command here. It's really text file, right? Perfect. So, for example, if I manipulate the magic number information here, let me manipulate here. I will put some string here that I know what this information means. I will change here and I use the file again, .text, .text, and let me check here and here, looking this incredible information. Now we have a Python script. In this case, is an executable file, right? So if it's executable, I can call it. I can call maybe Python. After you think about it, so I can call on not Python text in this case, text, because it's Python, right? If let me read again this file. Yes, but we have a problem. Maybe you can think about it some, but the extension here is different, right? Just let me, because I have another Python here in the other representations, I will. Okay, so I have here. Yes, okay. So let me change now here malware. Let me move malware text to the malware.py, right? So here we gonna py. So in this case we can run now just py. Maybe you need to have the authorization, the privilege to execute this kind of information. Maybe let me change here. Okay, so now let's Python again and let's check. It's the same error. Why did this happen? Because it's not a script Python, right? If you, for example, you can manipulate again this information here. It's very interesting point. Another again. Let me move again and %pdf trust maybe slash dash actually 1.9, and I will save here and I will clean, and let me check here malware.py docpy. It's a PDF document. Take a look at the very interesting, that's a big point here. Maybe you can ask, so Philip, now the file command, it's not it's not a confidence command. I can use this kind of command. No, you need to use, right? But you need to understand all those bases, right? This is the very important thing. You never can believe in the extension because, of course, it's the same case when you talk about the strings, for example. If you see here the strings, the man of the strings, for example, here, the strings command, right? So let me check here. Strings command, string printed the sequence of printable characters in file, right? So here's the simple key. The many people never think, maybe because in the beginning of the description says, for example, for each file given, strings print the printable character sequence that are at least 4 characters long. Because of this, when you execute, for example, here strings that maybe you execute, for example, in the beginning of this, the many commands, for example, you you don't find, for example, the ELF information or MZ information on the PE information, right? For example, here, if you read here the XDEMP, any, let me check here, any 32, the Linux 32, maybe less. Okay, in the beginning you can read here the ELF, right? So, but here you have just three characters, not 4 in this case, right? So if you try here, for example, let me change here. If you try, for example, run the strings dash a, putting in the Linux. Let me put pipe here. Pipe less here, and you put pipe less here, and you try. Oops, maybe I receive some errors here. Oh, of course, I need to put the file correct. Yes. So here, if you put here in the beginning, take a look here. You don't find here the beginning the ELF information, because ELF is just 3 characters, not 4 characters. That is important thing, right? This is all those bases, right? That's very important when you mention here, right? So we explain more than ELF now. So basically, when you talk about the structure about the ELF or maybe PE, portable executable, you can see in the pictures it's the similar form, not exactly the same, but very, very similar, because we have the same header, you have the sessions here in the text or doc or doc. Oh my goodness! You have the text, you have or data, you have the data, and you have many sessions header. In the PA portable, we have, for example, the 2 parts first, right? The header and the sessions. Of course, it's divided on other parts, and you have, for example, inside the header, you have the DOS header, when you can see the MZ information, the signature MZ, right? When basically it's responsible to the creator of this kind of binary. And you have here the PE header, when you can find the PE signature, this information, and below you can see the sessions. Here is the information where usually the attacker can put your malicious code, usually inside this session, docs text, right? And when you try to analyze any artifacts, for example, you can find the UPX compressed or maybe a packer tools. This is a technique maybe many times the attackers can be using many different attackers. Usually the packer can encapsulate all the sessions inside the one of this packer basically, and you can, when you use some tools to try and find any information, you will find, for example, the packer information, right? You can't see this information in the session, right? So okay, so we talk about the PE and ELF structure. Of course, it's very, very simple. I don't have a time actually to explain all this binaries, because if you talk about for example, just a PE, portable executable from Microsoft, man, we have many hours to try explain and to try goes to inside all this information, right? So I will try to explain more than PDF structure, because basically it's in 4 mainly parts. The header, basically it's the same when you talk about another binaries. You have the header, right? You have the body, you have the cross-reference table, and you have the trailer, right? So here we have all those structure. In the beginning of the file, you have the version number. It's the same information collected by file command. Do you remember when you execute the file command, you can read actually the magic number of this information. You can find this information. You have the body, and inside this kind of body, you have many reference inside of this body. You have the cross-reference table here, and you can read here its location of object within the file for a random access. What the things means in this case is basically one structure referring another structure or another object inside this body in this case, right? In the trailer, it's the same thing. You have here a location of the certain objects inside the body. That is, you have many connections of these parts of this structure, right? So here I will show you one of my analysis in a PDF file, right, to try understand. I will use basically here, I used the PDF ID. It's very known tools provided by Didier Stevens, right? This is basically, I think it's installed in many Unix platform, but you can download this information in the blog website from Didier Stevens, as you can use this in Windows machines. Sorry, we have problem here with my demo. Let me try here. Okay, I will pause actually this demo, because here we have all those informations. You have the header, you have 15 objects here, and you have the 2 streaming, you have the 1 trailer, 1 cross-reference table here, and you have 1 trailer, right? So below this 2, we can find this informations, this slash, right, in this information. All those slashes are inside of this object. That's a very interesting point, because if you see in the man of the PDF ID, you can see this information that basically it's tool is responsible to print many strings inside of the PDF, right? So here we have another interesting point. We have the encryption file, and you have here 5 JavaScript inside this PDF, you know? So we can think about it. What do you think? You have a JavaScript inside of the PDF file. Maybe it's a safe or malicious. You know, I don't talk about the reverse engineer here, just to try to interpret it or to try understand of this file, right? And here you can see another information. Open action, it's 1. What this means in this case, open actions refer basically when the user receives the file and user click in a file, in this case it's PDF file, and after that the file can execute something. In this case, we can see here we have 5 JavaScript. We just need to understand what this what this command represents in this case, right? So I will put more. Let me check here. Okay, so here I will use another platform. In this case, it's a PDF run, right? It's another platform created by Didier Stevens, PDF parser, right? Oh my goodness, we have I will have many problems here with my, in this case, my finger, you know, because I am clicking in a mouse. But no, but now I will try to show you the all those information in this case, right? Because I will pause the video to explain. As you can see here, this information in the beginning, we can see the header, right? And here you can read the object 1. If you remember when I explained about the body, about the cross-reference table, all those parts of this PDF are connected one above another, right? So here, for example, you have the object 1 referring object 2, object 3, 4, 5, 6, and 7. But you know, and I know that we have 15 objects inside this file, right? So let's continue to try understand. Here we can see the, my goodness. Here we can see the JavaScript, but here we can't understand what this information means, right? So we need to try understand more. Here, as you can see, we have the open action, as you explained before to you, right? The open action, when the user click in this file will run someone or any JavaScript, but we don't know, right? What this JavaScript maybe call it, or maybe can call it, right? So let's continue to understand. We have object 1, and here I will put, okay, more above here. Object 4, we have another reference here. We have a reference 8 and reference 9, and we have a 2 more referencing, right? So you can see here more connectivity in the many objects inside the PDF, right? So here another interesting thing. We have the object 7 connected or referencing by object 10. You know, we are growing up of this PDF file, right? And here, the object 9, we have the same case. We have the referencing the 4, because the 4 connected to the 9, and the 8, and the 11, right? So we can see many connections of the object inside this name of body, right? So here we have the object 10 connected to 12, and here we have one first interesting information. Object 11, we have the contain streaming. In this case, when this object has some strings, maybe you have a JavaScript inside this, or maybe you can have some exploit inside this. And you have this information flat decoded. It means these are streaming are obfuscated, are closed inside this flat decode. You need to decode this information, by the way. So here, another information is you have object 12, it's connected to 13. And if you compare here, this streaming, it's much bigger than another that we saw later, right? If you compare this streaming, it's very, very high. The size, it's very high, right? When you compare here. So maybe the idea is to try to looking all those informations inside this object, right? We have here the object 14 and here the 15 and finish the file, right? So the next steps is to try to look inside the object 13, right? So in this case, I will use another tool, PDF TK. In this case, this tool is not from DJ Stevens, by the way. So I will run the dump of this information, and this a key information, uncompress it, because I will uncompress all those information inside this PDF, right? Because you remember I run the PDF parser and I can read all those run information, and here I can uncompress, because I know inside of this streaming we have a flat decode information. So now I am seeing here the JavaScript obfuscated. In this case, the attacker used the first technique, the obfuscation technique, right? Because I can see the evil parameters and I can try to find any information inside this obfuscated code, right? So here I will use the nano. You know, I can use VI maybe, or another tools to edit all those informations, and I will just change any information. Here you can see many informations in JavaScript. So here we can find, or you can try to read any information, because you can, if you imagine, for example, we're gonna talk about the JavaScript. JavaScript usually the following, it's a application, a web application page maybe. So because of this, I will try to disobfuscate this kind of code. So because I have here the parameter, I will use in the script HTML, I will use in the document right to try read any information inside of this code, right? So I generate the payload.html and I will try to read if I find, for example, any information inside of this JavaScript obfuscated, right? So basically, I will run now this code in a HTML page, and I'll take a look all the the interesting information that we find here. The variable payload. Do you know what this means? It's basically the packer, or not the packer, the package responsible to download in the Vitman machine, and this package is responsible to response this information to the attacker server, right? It's known, the name, it's a CAC, or command and controller, right? So take a look. In the first step, we find the PDF file. And this PDF file, we have a 5 JavaScript, but we have one of this Java, it's the bigger JavaScript, and this JavaScript had received the obfuscated technique, right? And after that, I needed to change all those information. I need to disobfuscate it of this code, and when I execute this information in an HTML page, I can find the payload responsible to download in the victim machine. So if you remember in the beginning of this analysis, when the user, maybe the victim in this case, click in the file, do you remember the open action? The next action of this file is to execute this JavaScript. In this case, it's obfuscated. So when the user or the victim click in this file, this is scripted, the JavaScript will run in the victim and will download this payload that you can see in the screen inside the victim machine, right? So in this case, I was thinking when I was doing this analysis, so if I have the payload, maybe I can try to find the CAC from the attacker, right? So I will continue to do my analysis in this case. So I have here some information inside this payload, right? So here I will use again my big friend Nano. Maybe many people don't like this friend, but it's, in my case, it's simple. Oh, I could use again Vim or VI or another edit test. So if you see here, we have a very percent inside of this information here. When I look at all those percent, all those information, I can see here the interesting information in this case. Here we have you see two based on Unicode, information. It's almost different when you talk about the ASCII or ASCII. ASCII, it means 1 byte. When you talk about the Unicode, you use then 2 bytes, right? So here I have the pure, not pure, but the run data of this Unicode, right? So now I need to translate all this information. So I had the payload package, but when I see another technique, the encode technique, right? So this payload is used with Unicode encoding, right? I know it's maybe confusing, but take a look at this. I have a payload package. I have an information. All those information receive an encode technique. This encode technique is based in Unicode, right? So basically, as you can see here, I just using the Unix platform, but maybe you can ask, or you can asking, Filipi, but I use just Windows, but not a problem. However, you don't need to have a concern in this case, right? So here I use another platform, Mozilla by Bobby. It's a similar platform. I have here the same code. I need to cut. Do you remember? I need to cut this percent because I need to have the run Unicode information, right? The Unicode code, right? So here I have the Unicode information, and I can generate here the exa file binary. This tool is responsible to generate this kind of information. After that, I used another information, another tools created by Didier Stevens, short search executable, to try find any HTTP information. Because remember, if I have the payload package, probably this package, when after to download it in the Vitman machine, probably this package will make some request to the command and controller from attacker, right? So that's my idea when I to continue to do this investigation. So as you can see here, I found the IP from the attacker. In this case, the IP is based in Estonia, Europe, right? So this is information from the CAC, the attacker. I don't use it basically here, the reverse engineer, but we find the JavaScript obfuscated. We find the encode technique based in Unicode, right? We can learn about for example, the open action inside the PDF files. So we can learn about many informations, right? So if you have any question, I am available to you. This is my contact again. And one more time, thank you for this opportunity. If you have any question, please let me know.